required for the algae growth, basically nutrient and micronutrients. Okay. So flue gas can be used. Yes, we can. The problem is actually engineering problem, not a other biological problem. That how you take carbon dioxide from the flue gas, bubble it through the raceway pond, so that algae can take it for its photosynthesis. The problem is that carbon dioxide is sparingly soluble in water. So the moment you bubble it, the height, how much you are maintaining, how much, these are actually engineering design problems, and of course little biological issues also. By the time the algae takes it, most of those will again go back to the atmosphere. So that is the issue. Still nobody could actually provide a solution for this. People are still working. Okay, IIT Madras, IIT Go, Delhi is also working on certain project. I know that with Professor Malik's group and all. So it can be done. And the another buzzword is the 3R, that even you know some of the walls of your university is painted with that. I was showing yesterday or with Sambalpur University also. I forgot actually. No, while I was coming from the Jharsuguda airport. Okay, in that. So 3R. Okay, recycle, reuse, and reduce basically. Right. So that is the buzzword for any such biorefinery things, that you actually reduce, recycle, and reuse the waste streams. Doesn't matter whether it is a gaseous stream, gaseous waste stream, liquid waste stream, or solid waste stream. You need to actually recycle them. Right. Next. Yeah. So this is some work what we have done. I'll very quickly go through it. Okay. We are already running late. So what we did is that we have isolated certain strengths, algae strengths, from the wastewater treatment plant of IIT Guwahati itself. Then took that domestic sewage wastewater, okay, and grow algae over that. Okay. And we found that a particular species which is Monorhaphidium, our students named it as KMC4. Okay, genetically found to be actually Monorhaphidium species. Okay, gave us good result. Okay, other strains are also fairly good. It's not that they are not good. This is supposed to be best among these 8. Then the algae was harvested. Harvesting is an energy intensive process, still at it. People are working, even our group is also working to find out autopropagation methods, how it can be done. People are working, and there are other ways to reduce the energy that is required to harvest algae. Because most of the post processing, after the harvesting, you need a dry algae. Okay. So that is the reason that you need to dry, harvest it properly, and then dry it. So that is, you can see the dry algae, that heat triangle, and you can see that. So then we extract the oil. Oil goes to transcriptification. It's a known technology. Nothing new to do on that, except that you make some catalyst to go for some low-cost catalyst. Okay, that's the only thing people can work on. Right, and you produce biodiesel. So I am interested morely on that below part, that once you extract the lipid from the algae, what is going to happen with that? We need to work on that, because that is what you can aim for multiple products under the biorefinery concept. Right. So yeah. You skip all these things, so I don't want to question. So you skip all these things, go to the hold on there. So this is the bioremediation profile. Okay, here you can see that ammonia, nitrate, phosphate, and the overall chemical oxygen demand, the overall COD, got reduced from 85 to 99% in that range. Okay, which is actually very good using this particular algae species within 13 to 14 days of time. Okay, so this is the bioremediation profile. Then we harvested the algae. Okay, so since I'm a chemical engineer and many of my students are also chemical engineers, we are always thinking that how can you increase the biomass productivity and all such things. So we went for some 25 liter photobioreactor, PBS stands for photobioreactor. Okay, these are some in-house laboratory experiments. This photobioreactors are also been created by my students in the lab. Okay. Then we again went for head-based study. So you know, in chemical engineering, when you use head-based, you essentially work on to increase the selectivity as well as yield or productivity, right? you are reading chemical reaction engineering, you will understand that. Okay. So what we did is that carbon dioxide and light both we doubled it in each 7 days. Okay. So that's how the fed batch worked, and we got very good results. Yeah. Next. So you can see that the whole so we can see from here that the flash study give us almost 1.547 grams per liter of biomass. When we went for the 25 liter photobioreactor study, it was close to 2.4. Then the same photobioreactor with fed batch approach has given us close to 3.5. Okay. So this you can understand that with in-house process optimization with the fed batch and light, carbon dioxide, this is what is optimization. Okay. You can reach from 1.5 to 3.5, it's more than double the biomass of the initial study. Yeah, next. Then this is how this strain is very good. So using auto sedimentation, it was actually collected. You see the biomass slurry, algae slurry, and then the lyophilized biomass. Okay, the dry biomass. Then yeah, next. So these are some of the characterization of the biochemical and elemental composition of the biomass, which is after the lipid is extracted. Next. I'll not talk about this, we will skip that. Yeah. So I'll talk about this another 5-6 minutes. This is one approach where after we extract the lipid, whatever the biomass that is left out, which we call LEMB, lipid extracted microalgal biomass, and what we are going to do that. So the lipid goes to biodiesel, and what is left out? Next. Oh no, this will skip, you don't have time. Yes, hold on here. Oh no, yeah, hold on there. Yeah. So this slide you can see that. So the lipid goes to transesterification, which produce biodiesel. Fine. That's a known technology that I already told you. So what we are doing with the LEMV, two things we did. We are doing many other things also. This two I am showing right now here because this is already published work and all. Okay. So part of that we actually gone for the hydrolysis. Okay. So then what we found that interesting. Okay, it has a lot of carbohydrate. So it results in 25-20% of the sugar. Now that sugar, okay, that is hydrolysis, right? So we just used the Saccharomyces cerevisiae, okay, the yeast, right? And some optimization, and then we got 1.2 grams per liter of the ethanol, okay, bioethanol. So ethanol is very much important for us now. Government has mandated 20% ethanol blending, but we are not producing that much of ethanol. We are still importing ethanol from other countries. Now slowly, government has mandated that all refineries, doesn't matter whether big or small, should have some bioethanol plant. Okay. Now NRL in Numaligarh is doing. Other ISL refineries are also doing. NRL is Numaligarh Refinery Limited. They are coming up with a very big bioethanol plant, bamboo based. Okay, from fast growing bamboo. Okay. So look. Then the other part, what we did is that we went for the HTC, hydrothermal carbonization, and we produced biochar. Okay, and you can see that this side also that aqueous phase, something is floating, that is also some organic phase. It's basically some sort of oil. So what I try to say from this particular slide is that nothing is waste, right? So absolutely nothing is waste. So that HTC is hydrochar. You know, hydrochar is getting, or biochar, just since we are producing it using hydrothermal carbonization and calling it hydrochar. The reason hydrochar is gaining a lot of importance, I came to know it from my Korea visit last year. You know, Korea is the leading, South Korea, okay, is the leading producer of world cosmetics. It produces almost 40 to 45% of the total cosmetics that the entire world uses. Okay, you are using the mask, okay, carbon masks and all these face masks, okay, and there are other things, toothpaste mein carbon. So all these things are there, na? So these are for human consumption. So when you talk about for human consumption, you have carbon or char, whatever it is produced, it should come from a benign environment. So nothing better than hydrothermal carbonization can be, okay, as a benign environment. You cannot use any chemical or all such things per se to produce char, which is not acceptable, right? So in this way, this is but please understand that the small reactor is 20 lakhs rupees. That's why I am telling you, because the capex, the entire capital investment for such things under this high energy intensive Okay, conversion process is very costly. But any plant, there will have a lot of capital investment. So after 3-4 years, they will reach break-even, then their product profit will start. So it happens any plant, even if refineries also. So, but you see that here 1.2 grams per liter in 30 hours, 38% yield of hydrocharge looks little less. Why? Because this we are producing from the waste, which are anyway people were throwing it. Okay, so basically waste to resource recovery. Okay, so when you scale it up, that 1.2 gram liter will become 120. Okay, it will become 1,200. It is a scale of business basically, right? So this is from a small 10 ml or 5 gram, 2 gram like that. Okay. So this is a more holistic approach. Yeah. So go to the next slide. Oh, no, this skip all these things. There are so many things. No, this skip. Yeah, skip. I'll tell you. Just skip on. Skip. Go ahead. Go ahead. Yes. So hold there. Yeah. One more. No. Go ahead. Yes. Go ahead further. Yes. Hold. So this is the overall process. Okay. So what we did here, you can see that we start with the domestic sewage treatment plant. We have taken the liquid, that means the wastewater only, and grown algae over there, right? And whatever algae we got, then it is converted to two things. So as it is, we have used the wet biomass, okay, in the hydrothermal liquefaction process, right, along with the solid waste. Now what is the solid waste from the STP? It is the sludge. Now you know that sludge, people are sludge techno, you will see that sludge is extremely valuable. Okay, it has so many nutrients and so many metals and other things. It can be used for various purposes. So we have used sludge plus this wet biomass without making it dry, okay, and convert using a hydrothermal liquefaction, and what we got is biocrude. You will see that biocrude, there is some gaseous fuel that is also very interesting, but I am not going to tell about that. Okay, so that biocrude is exactly matching with the properties of the petrol crude. Okay, so that means I can go and distill it. So what we have done the distillation also using the micro distillation. So it has given different cuts, naphtha, then here FTF and all these things, kerosene, petrol, diesel, and the profile is more or less and the temperature is more or less similar to that of the petroleum refining. Okay. So in the below you can see that the dry biomass has gone for biodiesel and hydrocharge. So you can see that overall we are treating the solid waste, we are treating the liquid waste because we are growing algae over there. One part is done, that is bioremediation. So we are getting a treated water, and that treated water we are again recycling for the microalgae culture purposes. Then using the solid waste of the treatment plant, STP, that is our sludge, and using it directly with the wet biomass, we got produced. I'll tell you what is the why we use, because it has a lot of metals inside that. Now these metals, when it get inside the STF, they are using or they are acting as catalyst. Okay, so the entire process becomes faster, right? And this is the overall process. I think I'll stop because we are already running late. Can you go to the next slide? Let me see if I have that. Yeah. So this is the last slide that I want to tell you. So this is the scale-up. Okay. So this is the scale-up based on what the early slide of 1 million liter and mass balance. Okay. Now see, this is a theoretical mass balance. Now you want to do exact mass balance on the industry. The figures will change at least 5 to 6%, even sometimes 10% of it. It doesn't matter. Okay, this is a holistic figure you can say. So if you start with 1 million liters of domestic sewage wastewater, we get 2490 kilograms of the algae biomass, that KMC for species. Okay. To change the species, it will be different, right? So then when you go to that side, this is the upstream side, okay, and that's the downstream processing side. When you go to the algae biorefinery part, so use the dry biomass in the and go on for the co-processing with the 622 kilograms of sludge, we get 980 kilograms of crude. And you see the cut. This I wanted to tell you. 99 kilograms of petrol, 234 kilograms of kerosene, 250 something I am not able to see properly here, diesel, and the industry fuel is the last bottom product. Okay. Then come down here, you see we extracted the lipid. It goes to biodiesel. We get 632 kilograms of biodiesel, and again whatever the LEMB, that's the lipid extractor biomass, and 1771 kilograms converted to hydrochar, we got 970 kgs of hydrochar. Just see how many products. Start with petrol, kerosene, diesel, industry fuel, come down, hydrochar 974 kgs, then biodiesel 632 kgs. So this is the scale of chemical mass balance. As I told in the beginning, that numbers will change when you actually do it on the ground level. Okay. So I think I'll stop here. So there are many things to tell, but we are already running late. So there are other speakers waiting also. In case you have anything to ask me, you can just quickly go and ask. I will happy to answer. Or I'm there today and tomorrow also. We can discuss during lunch or dinner or whatever. So, thank you.
Thank you so much, sir, for such an illuminating presentation. I would request our chairman, Dr. Pankaj Jaran Jaina, sir, to come upon stage and felicitate our guests. Thank you so much, sir. Moving on, our next invited speaker for today's session is Professor Dr. Prakash Kumar Sarangi, sir. Dr. Prakash Kumar Sarangi is a senior scientist with specialization in microbiology at the Central Agricultural University in Impal. He received his PhD degree in microbial biotechnology from Ravenshaw University, Cuttack. He has more than 12 years of teaching and research experience in biochemical engineering, microbial biotechnology, downstream processing, and food microbiology. He has published more than 60 peer-reviewed journal articles and 40 book chapters. He is the editor of several books for Springer, CRC Press, and IK International Publishing House. Dr. Sarangi also acts as editor in PLOS 1, associate editor in reputed journals like Critical Reviews in Biotechnology, Biofuels, Bioproducts, and Biorefinery, and 3 Biotech. He acts as the guest editor in Biofuels, Bioproducts, and Biorefinery, Chemical Engineering and Technology, Biomass Conversion, and Biorefinery. He is a fellow of the Society for Applied Biotechnology and a life member of the Biotech Research Society of India, Society for Biotechnologists of India, Association of Microbiologists of India, Indian Science Congress Association, Forum of Scientists, Engineers and Technologists, and International Association of Academicians and Researchers. So, I would now like to invite Dr. Prakash Kumar Sarangi sir onto the stage to give his presentation on the topic Biotechnology for Pineapple Waste Utilization towards Sustainable Food, Energy and Environment.
Students and staff of this college service, and this topic is concerned. It is sir already told all the things regarding to this, how this biomass has been converted to this biofuels, regarding all the things. And this topic is complete based on the pineapple. As this production of this pineapple is used in the northeastern states. I have and how this pineapple waste can be converted for our sustainable food, sustainable environment, as well as also sustainable fuel, as well as energy.
जो ये दिया था सेरेमोनियल दिया तो उसको उठाया था.
Yes. Through all these slides, just a few different types, all these sustainable coffee. How this sustainable pineapple waste and through the help of this biotechnological tools, and how this biotechnology has the scope, and how this biotechnology scope is there for the conversion of this pineapple biomass to the sustainable food, energy, as well as sustainable environment. Yes. In this case, go for the starting one, and this pineapple is produced a huge quantities, and the real the structure of this pineapple is consist of its cellulose, hemicellulose, go for lignin part, and the real scope of this lignin, and from this real scope of the cellulose and hemicellulose, and this cellulose and hemicellulose can be converted to fuel part, and this lignin part is converted to all types of biochemicals. So, through all these type of slides, this part has to be covered. Next. Yes. 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 And from this pineapple, just have a look. All sorts of biomass has been got produced, and this is called leaf part, and so it is got separated, and its core part is got sealed, and the last part is the pomace part. And when this juice is collected, and from this juice the remaining part is called as the pomace part. And how this pomace can be converted to also value-added products, and through this help of biological steps. Yes, yes. From this case, just from the slides, it shows that how much step and how much over peel is just contribute. And suppose so in this case, go for all this pineapple fruit. It's a half and it's a higher than half also. Just go for it's all this biomass has been thrown out. And from this case, just have a contribution go for peel part. It just peel part is over more, saying that go for higher than 20. So from this case, our actually its main aim how this peel part and core part has to be converted, and through the help of this biotechnological tools, and its application of this biotechnology, and go for its value addition. Yes, yes, yes. From there, so many slides have you just look how this biomass is got as produced when this pineapple is caught, and when this pineapple is produced, so many things. Yes, go ahead. Yes, next. Because all these really slides have been shown out how this pineapple got is produced, so many type biomasses. Yes, then yes. So type biomass is doing. Go for a lab also. As my lab is specially go for this biomass conversion, go for value-added products, and specially go for this pineapple waste only itself. Next. Yes, yes. And from this case, go for pineapple is dried inside a dryer. Then, yes. And go for this structural part. How this has pineapple has its structural components. And all types of biomass is components of these three types of basic compounds. And these three types of basic compounds, have a look, it's called cellulose, hemicellulose, lignins. Next. Yes. And go for it's a structural binding of this cellulose, hemicellulose, upper lignins is also there. Yes. Next. Yes. Keep also that. Yes. So, from this case, must go for the production of this pineapple, and this production of this pineapple go for global cases. Just have a look. How much the tons of this pineapple is got produced, and how much this biomass has been also got generated. And if it, the data is showing that the pineapple, its half part is thrown away. So half of this pineapple is got actually. From this data, so have a look at how much of this pineapple got generated in every year in all sorts of the police countries, and in our just country it is also going that 1.9 million tons of this pineapple state produced, and half of this pineapple state thrown out. From this data, it is huge scope of this pineapple biomass, and how this pineapple biomass has to be converted to the biorefinery concepts, and through state help of the biotechnological tools. And these biotechnological tools can go for the production of all sorts of compounds. Next. Yes. So from this data, it is just the going for the pineapple the production all sorts of the world, and so in this case the first country is go for the it is and in this case just have a look our this country. It is the production of this pineapple, and through this pineapple we can get sorts of this compounds is also there. So slightly go by one. Next. Yes. Yes. So as already the sir has just already told. From this case, some of the compounds has to be studied, and just my lab also, it is just standardized scope for production of such type of compounds from the pineapple, and from this pineapple in your lab also such type of compounds is got to be produced, and specially go for this production of this biogas and biohydrogen part. Then okay. So not for this, must go for this fuel part. So go for this fuel part. We can go for this food additives. Go for this also industrial. It is also called from the healthcare products, and all sorts of compounds can be also done from this pineapple waste. Yes. Go ahead. Yes. So. From these slides, the huge scope and how this pineapple can be converted to biofuels and biochemicals and bioproducts. It is already clearly visible, and such type of holistic compounds can be got through the help of biotechnological tools. And what are the biotechnological tools? Standing by just one by one. Yes. So as already mentioned, this is the called fuel, and this fuel is also produced from this pineapple also. Yes. Next. And these are all the steps actually. So these steps has to also skip out. So it is not so much essential. Next. Yes. Skip also. Yes. So. So in this case, have a look how this actually go for pineapple, and the step is the first step. It's the recalcitrant lignin part has to be removed. Why? In this case, the lignin has no role in production of this biofuel part. So the starting state, how this lignin has to be removed first. So the real step, the starting step of the removal of this calcitrant for lignin part, and then the two parts is remained. And these two parts go for cellulose, and the second part is called also this hemicellulose. And how this cellulose and hemicellulose has to be converted, and this conversion through the help of these biotechnological tools only. And how this biotechnology has the huge scope go for conversion of these types of fermentations of the cellulose and hemicellulose, and so that these two types of compounds can be produced for the go for this bioethanol production. So have a look and go for the step 3 actually. Step 3 have a look. It is the two types of fermentation is there. One is So, and this hexosal fermentation has to be called as a C6 fermentation. And this C6 and C6 and go for C5 fermentation. And then this from C6 and C5 the fermentation, and lastly go for the production of bioethanol. Next. Yes. So, so in this case, all sorts of steps, and these steps go for biotechnological tools, and these are the steps, and these steps can have told you how this actually bioethanol has been got generated, and the starting step is called it is the state hydrolysis, and the state hydrolysis, and this hydrolysis product can go for the fermentation, and in this case the third step, it is so much important step. Why? And this third step can go for the production of this bioethanol, and through the help of this C6 C6 as well as the C5 fermentation. And how this is going on? Yes, next slide. Yes. So in this case, just have a look. Go for all sorts of chemicals, and these chemicals how this to got produced from all sorts of chemicals that also got generated from this ethanol also. Yes. Yeah. So in this case, go for some references part is there for the how this bioethanol is got generated, and go for production of these all sorts of fuels, and so in this case also 2 my books has been published. How this called pineapples and all sorts of biomass it's got generated, and go for their conversion to the you can call the fuel plant. It is also it is seen from these books also. Yes. Next. Yeah. Yes. So it is go for the hydrogen part, as the huge scope of this hydrogen as go for its fuel part, and this hydrogen is contained the huge scope. The scope is regarding it is the height of like this. Why this go for nowadays? It hydrogen go for regarded go for clean and green natural fuels. Yes. Next. Yes. So, from this case, the biotechnological steps and tools is there, and go for this last part. Just have a look this microbial communities, and in this case, there are 2 types of communities is there, and these 2 types of communities has the great scope and state conversion of this biomass to straight direct to the hydrogen. So how the go for this hydrogen is got produced, and so in this case go for have a look at this. Look means the role of this biotechnological tools is there. Next. Yes. So so in this case, just have a look how this fermentation is taking place, and such type of things and such type of steps convert to the biohydrogen part. Next. Yes, yes. So in these slides, the job has a look. The production of these 2 types of compounds going on simultaneously. So the starting, the top one must go for the hydrogen, and this is got to biomethane also. And such type biomass has the scope has to be converted to the 2 types of compounds simultaneously, and such type of compounds is also got produced with the help of this dark fermentation. So such type of biotechnological tools is also applied, and such type of microbes has the capacity, the scope is there, and this scope has to be converted to the 2 types of compounds simultaneously. And as these 2 types of compounds is get joined, and this biohydrogen and biomethane, so in this case the biohydrogen is got produced. Yes. Then yes. So in this case the term it is called biohydrogen. This biohydrogen is a combination of biomethane must have got biohydrogen, and this biohydrogen and biomethane is got combined, and this type of fuel has the huge scope nowadays. and the first type coal is got produced from pineapple waste. So, to the help of this biotechnological tool also applied, and this biotechnologically how these has got converted, go to the biohydrogen as well as biomethane, and this type of combined, and this biohydrogen is got also produced. And such type of fuel has a huge scope nowadays. So, in my students started some of some of the jobs in this case also. How this biohydrogen set also produced. Next. Yes. Also, let's go for some references. Have you also looked? Propose the student is essential. Next. Yes. So next. Yes. Next. Step is there. Yes. So just have a look. It is a step how this biobutanol is also got as a produced, and the first type of fermentation is called ABE fermentation, and this and first type of fermentation is called ABE fermentation, and first type of called biomass is got converted through the help of this ABE, and this is called yes, next slide. Yes, next. Yes, yes. So, so in this case, just have a look. The real scope of this biotechnologically, the real scope of all types of organisms, and how these organisms has the huge scope and the critical potential has to be converted to hydrolysis part, and then the step 2 is called acetogenesis part, and also step 2 is called ketogenesis part, and last part is called methanogenesis part. And how this pineapple biomass has the huge scope, and it is also got converted to all types of steps is there, and so in this case finally got biomethane part. As biomethane is combined with by hydrogen, so it gone for the production of biohydrogen is also there. So, so in this case, all types of 4 steps are called combined, and these 4 steps are combined through the help of the biotechnology tools is there, and also steps are combined and go for production over biomethane part. Next, yes, yes, and from this compound, the huge scope of this biomethanol part is also seen, and how also this biomethanol get converted to all sorts of compounds. It's called olefins and gasolines also there. You can also just convert it to this methanol part. This means the scope of this conversion of these types of compounds it is also there. Next, yes. So in this case, just have a look how this has become methanotrophic as bacteria is there, and this as bacteria, and through the help of this biological steps and through the help of this biotechnological tools, and all sorts of bacteria have its capacity how to convert to this pineapple waste and to directly go for the production of your biomethanol, and all the steps is go for the biotechnological steps, and tools is also applied in this case. Next, yes, next. Yeah. So in this case, go for this conversion, go for this part only. As this at this first slides, I have already told you, all the conversion of this cellulose part will go for the fuel part, and from this slides we will go for the conversion of this, and through this we can go for this all sorts of acids part. Next, yeah. So it is very just go for clear part how this pineapple the biomass has been converted to so many types of called value-added products. Means they go for value-added products to ferulic acid, citric acid, or succinic acid, and the go for my lab also. From my lab, this all sorts of compound got also done. means this lactic acid, bromelain, and pectin is also got produced for the biotechnological tools. And there is a huge scope this citric, and also the huge scope of this lactic acid is also. So all sorts of compounds, how these compounds can produce this pineapple biomass, and through the help of this microbiological or the biotechnological tools, all sorts of the steps is standardized in my lab also. Next. And go for this already source of compounds is got also started in my lab, and from this also got so many over research journals also how this phenolic acid and how this comaric acids and how this go for hydroxybenzoic acids are converted and got produced from this pineapple. And such type of compounds are huge scope in some of the food industrial sectors. And the term is go for how these all sorts of biomass has go for production for the food additives. Next. So the real scope and the go for its application of all such type of compounds is there. Means how these compounds go for its natural antioxidant. And such type of compounds is called and so many just compounds. And this type of already compound is got has been produced in my lab. And next, and as far as the term is called hydroxybenzoic has been concerned, these are the real life compounds, and these compounds are nowadays it has a huge scope in some of the medicinal sectors. And such type of compounds produced from the pineapple biomass itself. And this pineapple step has a huge scope, and go for this hydroxybenzoate is also go for this. It is also called a flavoring because such type of compounds has a huge flavor, and this early flavor is also go for the food industries. Next, and specifically it go for this. It go for the compounds of the ferulic, and this ferulic is got produced from the biotechnological tool or the biocatalyst, and this catalyst is called FA, and this catalyst has the it is produced so many just called biotechnological tools is there, and biotechnological steps is also there, and how this compound is got produced from this pineapple waste, and all these compound is also got converted to the compounds is also there. And just to see that, and such type of called biomass or biocatalyst is has a huge scope in the food industries, also the pharmaceutical industries also there. Next. And in this case, all sorts of its application of this ferulic acid, how this ferulic has a huge scope in sorts of strengthening of veins, etc. Already I have already heard done. Next. So such type of already compounds has been known to you because it is already go for food ice creams. It is already used vanilla is there, and go for this vanilla that got produced from the pineapple biomass, and this vanilla. Called biovanillin. Why? For this vanillin is called produced pineapple biomass itself, and huge scope of this vanillin is called food sectors and perfumes and called pharmaceutical industries, and all types of compounds. How these all types of compounds got produced from this biomass also itself. Next. And such type of compounds already close to. Already certain compounds it is just very close to it is called X. Next. It is just so that how this jam is called jelly is also there, also some of the constituents of foods is there, and how this got produced and steps of help of this compound got. Next. So just have a look. Just my standardized Gopher lab is there, and Gopher lab how this the compound is produced from this pineapple waste, and this pineapple has the Gopher its peels and some cores is also there, and these peels and cores are dried. And these peels and cores are standardized for biotechnological applications. Tools is there, and finally these biotechnological tools by the help of this compounds is got produced. Next, yes, and go for data how much of pectin is got produced. Go for this pineapple waste. It is a seen that this go for the peel pad is produced such type of its percentage and core, and the final is the huge production of this pectin is has been seen from pomage pad. And as just it is mentioned, how these compounds has a huge scope of production in sort of all types of food additives and food products. Yes, yes. Next, so here go for buying it's the closing part. As Sarah has mentioned, to stop it. Time is so short is there, so it is not a matter. So as far as just conclusion part, there is only the 2 to 3 the terms is I have mentioned is how this pineapple go for it sustainable. Means how this all sorts of the pineapple biomass go for sustainable food, energy as well as your environment. How? So so in this case, all sorts of compounds got produced from this pineapple waste, and these type of compounds can help go for set of compounds go for food. Yes, next time. So in this case, it is I have already just shown to this. In this case, in this case, so it is seen that how these chemicals and polymers go for the it's all types of food additives is also. Next. Yeah. So that is my great the conclusion is just have a look how this pineapple waste has been used scope of this all 3 types of sustainability, because from my already starting that I have already go for these terms, go for its sustainability of food, energy as well as the environment, and this as well as sustainability can go for this bioeconomical and development. All these type of 3 types of things. Next. Yeah, so it is I have already just told you what are still then so in this case some of the biotechnological tools is there, and some of the go from culture is also there, and how this culture and how this biotechnological steps has been go for a production of all sorts of compounds, all sorts of. So so in this case, the all sorts of compound go for production, go for this pineapple waste biomass. It is called biohydrogen is called there. Also biomethane is also there. So all sorts of already steps has been standardized in my lab also. If you are interested, also go to my lab and I have also so look how type of compounds is produced in my lab, and such type of compounds can go for its also must go for food additive and go for also type of fuel pad. All sorts of things. It is coming from this pineapple. Next. Yes. So now it is. I have already informed to you. So it is not mentioned to anywhere. Things is there. Next. Next. Yes. Through this slide, just to have a look. It is a complete value chain. This slide shows you that. Go for the value, not yes. Through these slides, it is very just clear that how this pineapple, just in this case, and from this go for this harvested pineapple, and how this really pineapple go for its juice and jams, and then all sorts of things. Means all the parts of the pineapple is already fruitfully utilized. So. So in this case on the slides, it is clearly mentioned that. So it is very just suggestion go for my students and some of the researchers and those are interested to do in this sort of research for biorefinery concepts and biofuel spurt. Then next, yeah. So in this case, the dear students and some of the researchers and those are interested to go for it. The scope is there. Next. So in this case, just also myself as also it is a go for some of the guest editors in some of the journals, and social journals is good also impact factor, and those students are really interested, and also researchers are interested also, and they can also just collaborate, and we can also take over. Next, yes, also the myself has is doing some of the long-term journals is also there. Next. Yes, just my go through the publication related to the biomass conversion and how this is called, the biomass has to get converted to value-added product. And special go for this pineapple journals, it is how this pineapple waste is converted to zero waste conversion. Next, keep out next. Yes, yes, yes. So anybody is interested, also go for such type of books is also there, and these are called as reference book. How this already conversion of this biomass, and especially pineapple waste, and these students and our researchers is interested, so go for their references. So have a look also. Next, next, next. So it is just go for all the students and the staff over here. So stop is here, and have some doubt also. I can also now also practice some of the services there.
Thank you so much for such a brief presentation, sir. I would now request Dr. Kortuba Mohanty, sir, to come upon stage and felicitate our guests. Thank you so much, sir. It was really an honor to have such profound individuals among us, and I'm sure all of us have gained quite a knowledge today. With this, we have come to the end of today's first technical session. Thank you everyone for being such a patient audience. Now, we will be moving on to the offline technical presentation session, which will be chaired by Dr. Rajesh Srivastav, sir, and Dr. Akhilesh Kumar, sir. Please give them a huge round of applause.
Good afternoon, everyone. Now we will be beginning the oral offline presentation session. First, we will be beginning with Mr. Kamalakant Sahu, who has the title with the abstract Nitrate Risk Assessment to Human Health and Possible Remediation Strategies in Odisha State.
Hello everyone, I am Kamalakant Sahu, research scholar from IIT Delhi. Today I am going to present my paper titled Nitrate Risk Assessment to Human Health in Odisha State and Possible Remediation Strategies. This is the outline. I will start with introduction, objectives, then methodology, resolution discussion, followed by remediation methods, conclusion, then rest. So as we know that recently United Nations World Water Development Report published that groundwater is plentiful but vulnerable to depletion and pollution. Once polluted, the groundwater aquifer zones tend to remain contaminated. Like there are many contaminants like arsenic, fluoride, nitrate. So here I am going to discuss about nitrate only. So nitrate is a common groundwater contaminant that can pose significant risk to human health. So the main source of nitrate is from agricultural activities, where we are using fertilizers and animal waste contributing significantly to nitrate levels. So hence monitor and regulation is required to reduce the nitrate levels in groundwater so that drinking water is safe. So here you can see that two figures. So first figures how nitrate from irrigated crops, the fertilizers and pesticides whatever we are using. So there how the nitrate is transported from unsaturated medium to saturated medium through different mechanisms, transport mechanisms like advection, dispersion and diffusion. So second figure show that, so there this how nitrate scenario in the Asian countries. So those are the Asian countries. India also impacted, that greater than 50 ppm, that is 50 milligram per liter nitrate contamination. Next. So my objective is to assess the risk of high nitrate concentration, which is impact to human health, so using 100% values. So there is a formula to calculate that, to analyze the risk and suggest remedial measures for the contaminated sites. So this is the methodology. First we have to estimate the nitrate concentration by taking the sampling sites. So we have to collect the samples
then analyze the nitrate concentration, and then data collection, like here value as per the IRI's database, and United States Environmental Protection Agency. Those data we have to collect, and some data from literature study and past reports we have to collect. Then calculate the CDI. Here CDI means chronic daily intake. Then we have to calculate the HQ, hazard quotient. Then special distribution, how variation of nitrate levels from one end to another area, so that we have to represent. Then finally risk analysis, whether this nitrate contamination is impacting to the children, pregnant women, or adults and old age, that we have to analyze. So this is the formula. HQ is equal to CDI by RFD. Here RFD means reference dose, that we have to calculate from US, United States Environmental Protection Agency. So this is the where C is the concentration. Here concentration, nitrate concentration. Then IR is the ingestion rate. Then EF is the exposure frequency. Then exposure duration AD. And EW is the body weight. Then AT is the average time. So this is the input parameter of the next. So this is the study area. Why Odisha I have taken for my research study, because there are confirmed 112 contaminated sites in India. Out of that, 23 contaminated sites in India. That is reported by Central Pollution Control Board. So these are the locations I have taken. So here you can see from the Central Pollution Control Board data, southwestern region are more impacted the nitrate concentration. So I have represented there how the variation is, that red mark shown that high concentration, so that high concentration 500 and low concentration 0 to 500, that I represent there. So special distribution of nitrate concentration is higher in areas close to agricultural fields where fertilizers are more. In urban areas, special distribution nitrate is similar. So here you can see that I have represented here hazard quotient values. 39 locations having hazard quotient values less than 1. That means, which indicates low risk of adverse health effects. And 21 locations having HQ hazard quotient value greater than 1. That means, which indicates potential risk to human health. So I have represented here adults and children here. Next slide. So for that we have to for these sites we have to remediate them. There is two mechanisms. One is separation based technology and another is reduction based technology. Like in separation based technology, electrocoagulation, membrane based nitrate removal technique, and capacity to deionization and adsorption, and reduction based, these are the process we have to follow. I have got from literature study. So in conclusion, rise in nitrate concentration from permissible limit, that is 45 milligram liter, that is Bureau of Indian Standard, the 45 milligram liter, that highlighted that influence of multiple pollution sources making groundwater vulnerable to contamination. So health risk assessment revealed that in this study the results found that revealed that adults are less prone to risk than children because of hazard quotient value greater than 1, that is more sites are related to children. So that's why we have to control that health risk in these areas, and future research will contribute to the formulation of appropriate management plans for the sustainable development of groundwater resources. And finally, nitrate contamination in groundwater can be difficult and expensive to remediate. Hence, prevention is often the best approach through careful management of fertilizers, where at what time we have to use the fertilizers, that we have to monitor the nitrate concentration level. So that's all. Thank you.
Thank you, Mr. Kamlaman Sahu. I would like to inform that the time of the talk is 10 minutes. It is a 7-minute presentation and 3-minute question and answer. So next, I would like to welcome Ms. Vinita Sahu, who has the abstract with the title Assessment of Seasonal Variation of Air Pollution Due to Brick Kilns by Evaluation of Leaf APTI. Welcome, ma'am. A very good afternoon to all of you. Assessment of seasonal variation of air pollution due to brick kilns by evaluation of leaf APTI. Next. This is the outline. This is the outline of my presentation. Introduction, area under research, sample collection. Next. So, as everybody know about air pollution, it is nothing but the presence of toxic substances in the atmosphere, which are mainly produced by the human activities like burning of fossil fuels. The gas like carbon monoxide, sulfur dioxide and nitrogen oxides are released to the environment, and along that dust and smoke also released. And my area under research is a area near Guriali village, Lakanpur Tehsil, Jharsuguda, which is famous for supply of clay bricks. And as it is on the bank of River Reef, so plenty of water is available. And as it is close to open cast coal mine, so coal is also plentifully available. Next, this is the process of clay bricks making. This is molding. Next, sun drying of clay bricks. Next, base layer of clay. They use this coal for burning of the clay. Next, then this layering of the brick clay. Next, then burning. Here you can see the release of toxic gases to the atmosphere, as this type of flame doesn't have any chimney. So the gases released from this kiln released directly to the lower atmosphere. Next, then this is the unloading process where the dust is directly deposited. Directly deposited on the leaf surface of the plant. Next, so these are the plants we have selected for our research. So these are the scientific name, and that side the common name. Generally these plants are available at that area, so we have selected these species. Next, we have assessed the biochemical parameters like leaf extract pH, relative water content of the leaf, total chlorophyll content of the leaf, ascorbic acid content, and all these 4 parameters are combined to find out the air pollution tolerance index. Next, this is the formula for calculation of air pollution tolerance index, and I have taken this formula from the reference. Next, this is the data. We have sampled 3 times for 3 seasons: winter season, summer season, and post-monsoon season. So this is variation of pH of leaf extract during the season. Here we can see that the pH shifts towards acidic side in winter and summer, and this low pH level may be due to the presence of sulfur dioxide, nitrogen oxide in the ambient air. And here it is an exception in case of lantana, that is maximum in case of summer season. So here we can see the maximum value of leaf pH, that is in case of summer, that is 7.85, and minimum in case of days, that is in winter season, that is 5.9. So for relative water content is lower in summer season, mainly due to dryness in the environment and also due to higher. So here we can see the variation in relative water content, that is maximum in case of post-monsoon, in case of earth leaf, and minimum in case of summer in bare leaf. Next. Then ascorbic acid content. Ascorbic acid content assess a plant's tolerance to sulfur dioxide concentration, and higher ascorbic acid indicates higher stressful condition for plants, and we can see ascorbic acid concentration is highest in winter season, and which is due to large amount of coal burning which release carbon dioxide to the atmosphere. Here you can see maximum ascorbic acid content was found in case of winter season in RC, that is 12.70, and minimum in post-monsoon season in Kurki leaves, that is 3.70. Then in case of total chlorophyll content, lower value of total chlorophyll is due to particulate matter deposition on the surface and alkaline condition caused by the chemical present in the dust particle, and this dust released from the bleaching fluid loading and unloading. So here the highest value in case of post monsoon, and in lowest value you can see in case of leaf. Next. So here in air pollution tolerance index, it is higher APTI of plant, is higher pollution in that location, and overall pollution is high in winter season. Here you can see the correlation matrix between the parameters. Here a highest correlation is a significant correlation coefficient that is seen in between APTI and ascorbic acid in winter season, that is 0.89. So here also a highest correlation coefficient is seen in case of APTI and ascorbic acid in summer season. Next. So in case of post monsoon, you can see a coefficient, higher coefficient in case of APTI and ascorbic acid. So this method is useful for providing valuable information to landscapers and well designers, and it helps in selection of suitable plant species for plantation in highly polluted industrial areas, and plants with higher APTI may be planted to combat air pollution as they are tolerant to pollution, and plants with lower APTI may be used as bioindicators as they are sensitive to pollution.
Thank you. चार्ज कैसे दिखते हैं इसमें नितिन चार्ज कैसे देखते हैं इसमें हाँ चल रहा है चल रहा है मेरा फोन से इससे शायद आउटपुट नहीं निकलता आउटपुट है ये इनपुट है शायद अबे ये
Thank you, ma'am. Next, I would like to welcome Dr. Rajesh Kumar Mahanti to the dais. The PPT, the presentation has been
2000 ml per liter, and they are able to also utilize the nutrients from in terms of ammonia, nitrate, and phosphate with an efficiency ranging from 92 to 95%. And for they get a very good inhibition index of something around 14 and 18% against the known causal agent for the bacterial leaf mold. First of all, we are trying to overcome others. We need a lot of water and nutrients for the production of microbes. So we are trying to minimize that. Secondly, is that one thing to work on is microbes. That how they are being talking, especially is antimicrobial agents we are talking about. So we have to see how this extraction is working. So whether cost is getting added in that or we can reduce that. So that is one of the ones. But as we know, one of the important factors how to make our business is the cost. Okay. So we have to work on that. Other than that, we can how we are going to use it. So this is basically till now what we have done in the lab where we are going to see whether the microalgae extract, these are the raw microalgae extracts here. So whether these microalgae extracts are acting against these bacteria. Next, what we have to do is that we have to find whether these extracts that we are finding, the microalgae extracts, so whether they are pre-emergent or post-emergent. Right. So after that only we will be able to decide how we are going to use. Because if it is a pre-emergent pesticide, then in that case what we are going to do is that we have to apply it before the planting of the seedling. Or if it is a post-emergent, then we have to wait till the seedlings grow and after that we can apply. Even it is just like the chemical pesticide that we are trying to go for that. This is comfortable to study.
Thank you, sir, for the wonderful presentation. Next, I would like to welcome Dr. Thangram Singh with the paper titled Hydrolytic Enzyme from Gangkyang Kui, a traditional fermented hibiscus cannabinous seed food of Manipur, India. Welcome, sir.
Good afternoon, everyone. Myself, Dr. Thangram Anand Singh, and I am from Central Agriculture University, Park. And the topic I am going to present is hydrolytic enzymes from Gangkyang Kui.
traditional sustainable food of Manipur, India. Everyone is talking about biofuel energy now, another form of energy. We are talking about food, and from this lowly food, we are going to get premium product. This is the permanent like enzyme, which is very nowadays a very important, I should say, in pharmaceutical industry as well as medical and medicinal industry. It is a sought after product right now. I'm setting down here. We know that our physiological system is blood. We want our blood to be in liquid form when it is inside our body. When we get hurt, we want it to be clot. We don't want to lose our blood. So basically, our physiological system is controlled by two opposite systems. So one wants the blood to be in liquid form when it is inside in our physiological system, and it is once it is hard and is broken, we want to stop the blood from losing by making it blood clot. So I am talking about this blood clot formation, and what if injury or something happens inside our body, and this blood fluid is clot. Blood clot is formed in our body, then this blockage is there, and they will support cardiovascular disease and stop everything that is we face from these things will happen. And for that controlling this enzyme, pharmacologic enzyme is used, injected or given orally to control to digest the clot inside in our system. So basically, I told you there are two opposite systems controlling our blood system. One is this, and coming directly to fibrinogen. Fibrinogen is the protein that will be digested by immune from and form fibrin. Fibrin is the base where this blood clot is formed. And then I told you the blood clot is formed in our system. It needs to be removed. So what happens? There is another protein plasminogen which will be converted to enzyme plasmin. The plasmin will digest the clot. The clot, and that will be degraded so that the block is removed. But something happens, physiological injury or hereditary or anything, then it is not digested by this plasmin in our system. Plasmin is not enough. Then what happens? Plasmin is not able to control digest the block, that injected or ingested this fibrinolytic enzyme. Fibrinolytic enzyme is nothing but a group of proteolytic enzyme that is able to digest fibrin. Now, this fibrinolytic enzyme, we get it from various sources. We get it from insects, some from venom of scorpions, snakes, and nowadays, but these sources are not very sought after because we want natural sources, that is natural food sources, which will not form any side effect in our system when we ingest that, because food is we are already having it. So traditional food, particularly fermented food, they are having huge loss of microorganisms, which is considered safe. Already we are taking it. They are called CRAS, generally regarded as safe. So these microbes are very good source of this fibrinolytic enzyme, particularly the microbe Bacillus. This is how this is how this traditional food is prepared. It is fermented. During fermentation, this microorganism can cause this is the seed, and that is the food unshankly is formed. And our interest here is not the food itself, but the associated microorganism. Okay. So from the associated microorganism, particularly Bacillus, we are able to extract fibrinolytic enzyme. Our objective is collection and isolation of microorganisms from long-term feed in the fermented seed of hibiscus, and the screening, extraction and purification of this fibrinolytic enzyme, and the molecular chapter about chemical characterization of purified enzymes. So methodology is simple. We collect sample and isolate bacillus samples. That molecular identification based on ARDRA and DNA sequencing. And is screened on hydrogen flash for pharmacologic activity. And the selected one that is second round, and the extract enzyme is purified, and the purified enzyme is further biochemical characterized, coding expression element going on. After that, we have this enzyme also molecular characterization. So what we got, collecting some results. One screening pharmacologic enzyme we actually isolated about 400, 386 bacillus isolated isolates were screened, and from 45 samples of food resistant food which is collected from various parts of our Indian molecule to the various districts. Okay, for now, that, and from that we are able to isolate 386 numbers of. Okay, next. Molecular identification is done using this technique, ARDRA and DNA sequencing. Then we are able to identify some dominant microflora, bacillus species, bacillus cereus, bacillus laciniformis, and bacillus decompressions are measured bacillus isolates, and others some mesophilic bacteria are also there. These two isolates, one is bacillus subtilis and the bacillus decompressions are not to have high physiological activity. So this is how we prepare it expected and biochemically characterized, and then purify as a specific activity at the level of 6.5. So this is how we deal with thermography as well as the space. We are able to purify up to the level of this one single band. Just the level next. So when it is characterized, and we are able to know that for the protease, scientific protease inhibitor, it is we get to know that TSSF is a serine protease indicator. So it is a serine protease next. And using this commodity substance is nothing but it's after digestion, color substance. Particularly ABC, I am giving ABC, but they are not complete. Carbohydrate, phosphate, like that, related to blood protein, blood cascade. Next. So this ongoing. Next. Concluding like this, bacillus subtilis and bacillus with this particular fermented food is very strong pharmacologic activity, and this pharmacologic enzyme so it is giving this characterization molecular as well as biological, and this draft get bacillus stress may be a potential component to source of novel super pharmacologic enzymes. Thanks. Please, sir, welcome. Actually, sir, the thing is, we are able to do this up to the level of laboratory lab. In vitro we can do, but after this is to be practically applied. I mean, we have to go further. Animal model testing we have to do. After that, we have to go up to the level of we have to go a clinical trial. This thing is not up to us. Sometimes we are getting very good results very much compared now in the international level, but still we are not able to go further into some which we cannot control that. Like clinical trial, we cannot do independently, and the big movement and other bigger organization has to support us. Other than that, we have done, I think, therefore, good enough for international community.
Thank you for the presentation, sir. Next, I would like to welcome Mrs. Swapna Sahu to the dais for her PPT with the paper titled Mechanical Properties of Carbon Fiber Reinforced LY556 Epoxy Composite for Prosthetic Food Fabrication.
10%
Respected chairpersons present in the conference, all the delegates, and dear students. Myself, Swapna Sahu, I am a PhD scholar and side by side also I am working as a demonstrator and College Development National Institute of Rehabilitation Training and Research. Under the supervision of Dr. Rashmi Goma, I am doing my research. So my topic is mechanical properties of carbon fiber reinforced epoxy composites for prosthetic foot fabrication. Next slide please. Composites are nothing but a combination of two or different materials with excellent properties and mechanical characteristics well. According to that, if they are used individually. Next slide please. This is the outline of the presentation. So I had used, there are two components of the composite. One is the carbon fiber, like which is used as a reinforcing material, and another one is the matrix. So I had used the carbon fiber and epoxy because of the unique advantages of the carbon fiber, like excellent strength ratio, very good thermal expansion, good heat resistance, for which they can be used in a wide variety of composites. Epoxy matrix also are widely used in advanced carbon fiber reinforced composites due to their very good compatibility features, very good processability, good chemical resistance and wear resistance. Nowadays there are wide applications of carbon fiber reinforced plastics in many areas such as like automobile, marine industry, sport industry. I would like to highlight a special application in amputate rehabilitation. Amputate rehabilitation, first we need to know about amputation. Amputation is nothing but it is a destructive surgical procedure to the continuity of the limb. So when the limb is amputated, it usually affects the quality of life of the amputee. So the person cannot ambulate. So the prosthesis remains the only option for the amputee to overcome the handicap and in order to mobilize themselves to live their lives independently. So when we are losing a foot, we can see the picture. We had fitted the prosthesis and has been also, and these are the components of the prosthesis. We can see that the prosthetic foot is a distal component and it is an integral component of the prosthesis. And the prosthetic foot exactly should mimic the biological foot or the physiological foot ankle complex. Otherwise, it will affect the phases of the gait cycle. When the pattern of the walking of the human being is known as the gait, if we are using our own foot, then that is known as normal gait. So the normal gait cycle should be substituted when we are using a prosthetic foot. So there are various designs of the prosthetic foot. In government sectors, we are using a solid ankle cushion wheel prosthetic foot. On investigation, we found there are lots of issues of durability, comfort, and also increased weight. So on the side by side, if we are using the energy storing food which are widely available in our market, these are very expensive, but on the contrast, it provides more comfort, safety, strength and durability because of the use of the high light flexible materials and also more advanced engineering technologies. So the fiber reinforced composites can be used in the manufacturing of an energy storing prosthetic wood which will provide a good mechanical response in terms of the higher stiffness and very good smooth impact response. So the school of thought goes in that in order to produce a cost-effective energy storing prosthetic wood for the active amputees, so the materials need to be lightweight, responsiveness and incredible strong. So many studies had focused that they are using different types of carbon fiber, so accordingly the properties also change. But when we are using a very good bidirectional carbon fiber and the optimal properties of the carbon fiber should be enhanced, then we can find out the mechanical properties of the carbon fiber reinforced composites can also be enhanced. So the earlier studies had mentioned the various manufacturing methods of carbon fiber reinforced composites, but the effect of the process parameters on the mechanical performance showed very inconsistency results. So if we are changing the composite mechanical properties based on the alteration of the reinforcement layers had not been investigated yet for the designing of the material requirement of the prosthetic foot. So the study objective, next slide please. So the study objective goes that to develop a carbon fiber reinforced epoxy composite with superior mechanical properties which can be used for the fabrication of the prosthetic foot. So the current approach presents a combined study of processing and also characterization of the carbon fiber epoxy composite. The effect of the number of layers of the reinforcing agent, that is the carbon fiber, on mechanical properties of the resulting laminate composites is investigated in this study. So the materials I had used in my current work is a plain woven carbon fabric, which is 400 GSM bidirectional carbon fiber, which was procured from CF Composites Delhi, India, and also the epoxy resin LY556, which is a diglyceride ether of bisphenol A with a hardener SYN51 epoxy hardener. Here we can see that the tensile strength of the carbon fiber which we had used, that is 4000 megapascal. So the tensile strength of the carbon fiber is enhanced, then the mechanical properties of the carbon fiber composite also can be increased. So the preparation of the composites are prepared by hand layer procedure followed by compression molding. And I had made 3 samples by incorporating 3 layers, 4 layers and 5 layers of bidirectional carbon fiber stacked one after another in an orientation of 0 and 90. So the process of optimization was done for the cooling time, amount of compression pressure and pressure holding.
9% कैसे चार्ज करेंगे?
So the experimental work I had done, that is I had got 3 composites, 3-ply, 4-ply and 5-ply composites, and according to that I had the specimen for the mechanical testing was done from all the 3 resultant composite laminates, and the mechanical testing of the composite material is really important to evaluate the fundamental properties so that we can control the quality of the material for designing a prosthetic foot so that they can be utilized in the loading activity. So first testing is the tensile testing of all the 3 composites, 3-ply, 4-ply and 5-ply I had done with the UTM machine according to the ASTM D68 standard.
iPhone support no need. Power bank no need. Adapter बस विचार.
According to the ASTM D256 test standard. And the hardness testing was done for all the composite laminates. So did durometer hardness, and this test was conducted according to the ASTM D2240 standard at 5 different points. And so you can see the depth of the conical indent of the durometer hardness, which determines the hardness of the indentation resistance of the composite material. So the results of the tensile properties, so here we can see the stress strain graph, and we can see that the tensile strength is exactly enhanced for the high percentage of layers, like 5-ply composite, it is exactly increased for the carbon fiber reinforcement 5 layers, which is a major factor to lead that there is a good bonding, good strong adhesion between the strong carbon fibers and the epoxy resin, so that we can say that the stress enduring capacity of the laminate is good for the designing of the prosthetic foot. When the results of the impact properties shows that the increase in the impact strength from 66.81 to 99.9 in the 5-ply composite, we can see that a strong framework is generated which significantly restricts the crack propagation and increases the impact. The results of the hardness properties are also seen like that. So when the fibers are added to the composite material, it enhances the resistance to the deformation. So in the hardness properties enhance that there is a good interaction generating a strong interface and an efficient bonding between them. So what are the next steps? So what are the required mechanical properties of the prosthetic foot? So the prosthetic foot demands that it can sustain the loads 1.2 times of the body weight during walking and 2 times of the body weight during morning running. So the angle during the gait phase when we are because we need to vary the steepness properties. So the controlled plantar flexion period, we need to adjust the steepness, and during the swing phase of the gait cycle, the ankle behaves like a non-linear around 3 to 4 foot. So
Hello.
the stress should be transferred from the heel
Hello,
into the
Nimeka.
subsequent portion of the foot. The findings
नहीं.
are correlated with the findings
का तू
and
खाऊ ना
references.
पाड़ा ना जा
So
सड़
that
तम मन खाए पे नहीं रे
work is to provide a
अरे कनेक्शन तो लगा पहले इसको
fabricating
नहीं नहीं
carbon
नोब्स
fiber
नोब्स
energy storage mode for lower manganese.
कनेक्शन कर दे देख कहाँ पे
The conclusion is
Knobs.
that the reinforcement of the carbon
मग
fiber
तसं यार मग तुम्हाला टाकतील होतं तो ये तू टाकतील तो
carried
एम
out by
डिपार्टमेंट
manual
छेस्टर
technique followed by compressed stress. The
I
properties such as
don't know.
tensile strength, hardness and impact strength were investigated and compared, and the from the results it is able to conclude that the 5-layer carbon fiber reinforced polymer is the preferable material for design and fabrication of the prosthetic foot as it shows very superior mechanical properties. Future approach by aim of the future investigation is to fatigue testing of the components so that we can know that how the prosthetic foot will perform over a given number of cycles to investigate the durability. Next slide, please. With this, I would like to conclude. This is a like of very research work is very high. So in a note of Albert Howard, like very little persistence and very good effort. I had created multiple times also, but which may turn to a glorious success. And for this entire work, I thank you guide, Dr. Ashwini Kumar Nagarkar, and also the entire team of the CIPET ICT Bhubaneswar, Mrs. Jasmine Madam and Vishwendra, who had helped me in this guidance of the testing because I belong to a hospital and orthopedic field. This is an interdisciplinary approach. So somehow my research journey is incomplete without them. So thank you.
नहीं मेरा भाई वर्किंग कंडीशन में
अबे चार
वहाँ पे ये वो काम नहीं करता था
अबे ना
तो देखते हैं अभी
उस साइड वाला में हाँ तो लगा के देखिए हाँ उस साइड कनेक्शन
कौन से टोटल इस साइड खाली वहीं पे आता है खाली वहीं पे आता है वहीं पे और वहाँ पे
अबे अभी नहीं सुन
हाँ
जहाँ अपना बैग रखे वहाँ भी आ रहा है वो बच्चे चार्ज लगाया ना पावर कैमरा
चुपचाप रूम
कैमरा चार्ज लगाया बड़ा है तो वायर ले आएंगे
देखते हैं
अभी नहीं सुन हाँ जहाँ अपना बैग रखे वहाँ भी आ रहा है बच्चे चार्ज लगाया
that you have synthesized.
Yes.
So, what are the major advantages which are associated with
Suppose if we take titanium dioxide and any zinc oxide in purest form. These are stable compounds, no doubt, but they absorb in UV. Right. So first motto is to shift the band gap in the visible region so that they can absorb easily, and even if they can be applied in the sunlight, so energy level means consumption of the energy level can be reduced very well, right? So when we move from the import titanium dioxide to the binary composite, the band gap decreases, right? And the charge carrier concentration also that not be combined, because recombination is the main problem. Whenever there is excitation, the electron again comes to the hole and recombine. It means the activity is goes. And if the secondary component is added, they channelize to the other. Means the electrons are shifted or can also migrate towards other. Means recombination reduced. If we add certain other ternary components, again they channelize to the third. It means recombination can be reduced, and even in this system, the band gap also reduced by from 3.2 to 2.8 in the binary and towards 2.7 in the ternary composite. So two main motors can be satisfied by these. One is the reduction in the charge carrier, so that recombination can be reduced and your catalyst may better work, right? And secondly, to shift the band gap towards visible, so that that can may be applied or can be excited in the sunlight.
Second, is there any effect you have added? Whether it is titanium oxide or I think after the formation of this ternary complex, I think the size, it is also the size of the nanoparticle or nanocomposite, it is also going to be affected.
Yes.
Meaning surface area going to decrease.
Not only the size, it's not definitely size decrease, but sometimes due to the addition of the secondary component, the seed growth that is affected. We cannot say size decrease, but sometimes the shape also differ. So definitely the surface area differ, but sometimes may be increase, maybe near about, or maybe decrease. But even decrease in the surface area in many of our, not in this, but in many of our composite, we found that despite of the decrease in surface area, the activity increased, because for the photocatalyst, first condition is the increase in surface area, so that catalytic site may be increased, right? And we can directly relate to it. But despite of decrease in the photocatalytic sites, we found that there is increase in the photocatalytic activity. That is only due to the formation of the heterojunctions and the higher absorption in the visible region.
Any question from the audience side?
Thank you, delegates, for the wonderful presentations covering all aspects of chemical and bioscience that you have presented. Now I would like to inform you that we will have a lunch break now. The delegates and all other participants are requested to move to the ground floor for the lunch, and all the invited speakers are requested to move to the cafeteria. Yes, I would also like to inform that there is a food coupon inside the kit that you have been given. Please take the lunch coupon with you. Thank you,
वहाँ पे मैं छोड़ दूँगा। चालू चालू चल ए चल चल
Hello, sir.
Okay.
Yes, sir. We are going to start right now.
Good afternoon to everybody. I am
Just
Bhima Rao.
just 1 minute, sir. Just 1 minute. We are starting, sir. Just 1 minute.
Okay.
Good afternoon, everyone. Honorable Chairman Dr. Pankaj Charan Jaina, sir. Respected Organizing Secretary Dr. Krishna Prasad Sharangi, sir. Respected professors, esteemed dignitaries, and my lovely audience. I am Angela Kundu, and I once again welcome you all to the second technical session of the National Conference of Chemical and Bioscience, organized by the Department of Chemical Engineering, V. Surendra Sai University of Technology, Burla. In this session, we will be listening to some more speakers who have excelled in their respective fields. We will be starting our session with the first invited speaker, Dr. R. Bhima Rao, sir. Dr. R. Bhima Rao is a retired chief scientist from IMMT Bhubaneswar. Dr. Bhima Rao has obtained doctorate degree in mineral engineering from Indian School of Mines, Dhanbad. To his credit, he has a few patents and more than 200 publications in international and national journals. He has delivered a large number of invited lecturers in national and international organizations. He is fellow and life members for many professional societies and fulfilled his duties as president and as secretary. He has organized many seminars, symposia, and workshops. His main fields of interest are communication, process flowsheet development for lean and off-grade ores, waste recycling, and utilization. In this area, he is expert member for various government organizations such as member for Bureau of Indian Standards, UPSC, SSC, BRNS, UGC, CSIR, DST, Government of India, and for few academic institutions. He has received many gold and silver medals and certificates for his best papers and recognitions, especially in the area of additives in grinding. An award has been introduced in the name of Dr. Raghupatrani Bhima Rao in the area of chemical engineering for best papers published in the annual technical volume of IEI OSC Bhubaneswar. Having said much, I request Dr. R. Bhima Rao sir to kindly give his presentation on the topic Microalgae Biorefinery, a sustainable way to reduce biorefinery while integrating wastewater treatment. Sir, please.
Madam, topic title is wrong.
Hello, sir. Sir, your slide is already shared.
Topic title is wrong. Madam, title topic is wrong. What you said? She has said algae.
Okay.
Let me correct, sir. Your title of the is Role of Reaction Kinetics, Development of Flow Sheet to Recover